Hello. Today we are talking about x and y intercepts of rational functions. So when we look for an x-intercept, we normally plug in 0 for y, but there is a shortcut when you're looking at rational functions. So I'm going to start the long way and then we'll look at the shortcut. So if I plug in 0 for y into this function, I've got 0 equals 2x over this quadratic trinomial in the denominator. If I want to solve for x here, I would have to multiply both sides of the equation by the denominator to get rid of that denominator. So I have to do that every single time. A rational function is a fraction, so I'd have to multiply by the denominator every time. So what's going to happen is that denominator is going to multiply out to give me 0 every single time, so I can just set the numerator equal to 0 as my quick trick to find the x-intercept. Here I would just divide by 2 on both sides, and I would get that my x-intercept is at 0, 0. To find the y-intercept, there's no quick trick. You're just plugging in 0 for x. So everywhere where you see an x, you are replacing that x with 0. I used that original function to plug in 0 here. Nothing canceled, so I could just use the original function. I end up with 0 divided by -3. Which is just 0. So my x-intercept and my y-intercept are at the same value here. All right, so I'm going to use the shortcut here for x-intercepts. I'm just going to set the numerator equal to 0. So I'm going to write 0 equals, and then I'm only going to write the numerator. I'm solving a two-step equation. I'm using inverse operations to get x by itself. I end up with x is equal to 3, or 3 is equal to x. So my x-intercept is at the point 3, 0. For the y-intercept, the step says plug in 0 for x. So that means that everywhere where you see an x, you are substituting 0 in for x. So instead of y equals 2 times x minus 6, it's going to say y equals 2 times 0 minus 6. Instead of x plus 1 in the denominator, it's going to say 0 plus 1. That's what plug in 0 for x means. We simplify the numerator. 2 times 0 is 0. 0 plus 1 in the denominator is 1. 0 minus 6 is -6. And -6 over 1 is just -6. So our y-intercept is 0, -6. Now for this last one, x squared minus 1 factors into x plus 1, x minus 1. So something cancels here. The x plus 1's cancel, which means that you have a hole in your graph. Because this gives you a hole in your graph, you can't also use that piece of the numerator to get you your x-intercept. So write your leftovers. You're left with y equals x minus 1. So to find my x-intercept, I'm going to set that numerator equal to 0. So instead of y equals x minus 1, I'm plugging in 0 for y, or that's the only numerator I have left. So I'm setting the numerator equal to 0. I solve, I get 1 for x, so the x-intercept is 1, 0. When I find my y-intercept, I also want to use my leftover function. So I want to plug in 0 for x into that leftover, the x minus 1. So here I have y equals 0 minus 1. That gives me -1, so my y-intercept is 0, -1. All right, so let's take that process and let's run with it. Remember that if you can factor and cancel, you need to do that first before you look for your x or y intercepts. Use the leftovers to find your x and y intercepts. Pause the video here, try the first one, we'll look at the answer, and then you can keep pausing and trying and checking. All right, so for number 4, your x-intercept should be -3, 0, and your y-intercept is a fraction, 0, 3/2. I set the numerator equal to 0 to get the x-intercept, and I substituted 0 in for x to get the y-intercept. Remember that for number 5, this numerator factors into x plus 3, x minus 3. That's called a difference of squares. You need to know how to factor to move forward in your math career. So when you cancel those x plus 3's, that tells you you have a hole in your graph, and the hole cannot be part of your x-intercept. So pause it and try it from here. So the leftovers for this one is y equals x minus 3. So when I set the numerator equal to 0, I'm only using what's left over after I cancel. Same with the y-intercept. When I plug in 0 for x, I'm only using the leftovers. When we look at number 6, that denominator factors into x plus 3x minus 3, but when these cancel, you're left with a 1 in the numerator. If I set the numerator equal to 0, 0 is not equal to 1. So I don't get an x-intercept here. I can use the same rule, but I just have no x-intercept because 0 equals 1 doesn't make any sense. There's no x left in the numerator. I do, however, have a y-intercept because when I plug in 0 for x, I get 1 over 0 minus 3, which is 1 over negative 3, which is negative 1/3. So really, you just need to memorize the steps. For x-intercepts, set the numerator equal to 0. For y-intercepts, plug in 0 for x. Use your leftovers. So if something cancels, use what's left over to find these particular key features. Have a great day. We'll see you next time.